defined, we're now going to navigate the world of variables and data types. This is the last requirements for computational thinking. So we're getting into the real nitty-gritty part of the curriculum and some higher order concepts. But trust me, it's much easier than you might think. Let's just take a look. Let's head back to my mobile phone. When I use a map app for seeing my location, it constantly changes as the app follows my path to my final destination. My phone uses GPS, which stands for Global Positioning System, and it targets my exact location using the values of longitude and latitude. For example, if you're at the Beehive in Wellington, your coordinates would be latitude, minus 41.27, and longitude, 174.77. When you move in your car, your GPS coordinates will change because your location changes. So how do I use this example to explain variables? Well, think of the GPS coordinates as the variables. In the context of my computer, and a variable is a block of memory, a computer memory that's set aside for a particular value. When I create a variable, I give it a specific name so I can easily tell it apart from other existing variables in my code. It's called a variable because the value that's stored in it will change over time. So let's bring it back to computational thinking. Variables refer to values that we need to keep track of while a program is running. Each variable has a unique name and contains a single value. The variable's name stays the same, but the value stored can change over time. Let's imagine a fictitious computer game called Outback Adventure. To earn points, you must collect items for survival. In this case, you may have the word score as your variable name, and the value will constantly change as you earn or lose points. Ask your students if they can think of another variables that may be found inside a computer game. They might come up with bonus points or the number of lives they've earned. In computing, the values of variables are not permanently stored on the hard drive, but they're held temporarily, only while needed. Imagine using the calculator feature on your mobile phone. You enter a number into the calculator. You can think of this as a variable. You then choose an action such as addition, and then add another number, a further variable. The answer to the calculation presents yet another variable or a value. Once the calculation is complete, the calculator gives the answer. The value of the variables that were used to calculate it have been discarded since their job is done. But let's use an actual example. Take it away, Dave.
Imagine you're going to code a game. There may be several different values you want to keep track of while the game's being played. One of these might be the current level the player has reached. Another might be the player's current score. There might also be something that stores the game objects, jewels, armor, friends, whatever, that the player has collected so far. Since these things can change over time, we need to store them as variables. Maybe you can think of other things that you'd want to keep track of in a game using variables. When coding, each variable needs to be declared and initialized before it can be used. Declaring a variable means adding its name to the code. Initializing it means giving it an initial value. Let's see how this works in Scratch. Making a variable in Scratch is easy. If you click on the data script, you'll see a button called Make a Variable. Let's start by clicking on that Make a Variable button. It will ask us to give the name for that variable, so we will call it level. Variables can be for all sprites or just one. Since the level will apply across the whole game, we will choose for all sprites. If you were making a variable for something like one character's energy level, you might choose to make it for this sprite only instead. Once the variable has been declared, it appears in the data script, along with some blocks specially created for that variable. It even appears on the stage, showing its initial value, 0. The checkbox next to the variable can be used to make this appear or disappear from the stage. What about initialization? When we declared the level variable, it was automatically initialized at 0, but we might prefer to start a game at level 1. So let's change that in the set block that's been created for our variable. We said earlier that the reason for having a variable is that it stores a value that can change over time. In our game, the level might change when the player has reached a certain score. So to make that work, we're also going to need a score variable. This code block gives you an idea of how we would use these variables in the game. There is a repeat block that contains some gameplay activities. It loops until the score variable reaches 100. This makes the loop finish, so the code goes on to add 1 to the current game level. Although we've only shown you a couple of ideas about how variables work, we hope that you can see how useful they can be when coding.